A fighter aircraft is a military aircraft designed primarily for air-to-air combat against other aircraft, as opposed to bombers and attack aircraft, whose main mission is to attack ground targets. The hallmarks of a fighter are its speed, maneuverability, and small size relative to other combat aircraft. Many fighters have secondary ground attack capabilities, and some are designed as dual-purpose fighter bombers. Often aircraft that do not fulfill the standard definition are called fighters. This may be for political or national security reasons, for advertising purposes, or other reasons. A fighter's main purpose is to establish air superiority over a battlefield. Since World War I, achieving and maintaining air superiority has been considered essential for victory in conventional warfare. The success or failure of a belligerent's efforts to gain air supremacy hinges on several factors, including the skill of its pilots, the tactical soundness of its doctrine for deploying its fighters, and the numbers and performance of those fighters. Because of the importance of air superiority, since the dawn of aerial combat, armed forces have constantly competed to develop technologically superior fighters and to deploy these fighters in greater numbers. And fielding a viable fighter fleet consumes a substantial proportion of the defense budgets of modern armed forces. Terminology. The word fighter did not become the official English term for such aircraft until after World War I. In the British Royal Flying Corps and Royal Air Force, these aircraft were referred to as Scouts. Into the early 1920s, the U.S. Army called their fighters pursuit aircraft from 1916 until the late 1940s. In most languages, a fighter aircraft is known as a hunter, or hunting aircraft. Exceptions include Russian, where a fighter is a, meaning exterminator, and Hebrew, where it is matos krav. As a part of military nomenclature, a letter is often assigned to various types of aircraft to indicate their use, along with the number to indicate the specific aircraft. The letters used to designate a fighter differ in various countries. In the English-speaking world, F is now used to indicate a fighter, though when the pursuit designation was used in the US, they were P types. In Russia, I was used, while the French continue to use C. Although the term fighter specifies aircraft designed to shoot down other aircraft, such designs are often also useful as multi-role fighter bombers, strike fighters, and sometimes lighter, fighter-sized tactical ground attack aircraft. This has always been the case. For instance, the Sopwith Camel and other fighting scouts of World War I performed a great deal of ground attack work. In World War II, the USAAF and RAF often favored fighters over dedicated light bombers or dive bombers, and types such as the P-47 Thunderbolt and Hawker Hurricane that were no longer competitive aerial combat fighters were relegated to ground attack. Several aircraft, such as the F-111 and F-117, have received fighter designations but had no fighter capability due to political or other reasons. The F-111B variant was originally intended for a fighter role with the U.S. Navy, but it was cancelled. This blurring follows the use of fighters from their earliest days for attack or strike operations against ground targets by means of strafing or dropping small bombs and incendiaries. Versatile multi-role fighter bombers such as the F/A-18 Hornet are a less expensive option than having a range of specialized aircraft types. Some of the most expensive fighters such as the US F-14 Tomcat, F-15 Eagle, F-22 Raptor and Russian Su-27 were employed as all-weather interceptors as well as air superiority fighter aircraft, while commonly developing air-to-ground roles late in their careers. An interceptor is generally an aircraft intended to target bombers and so often trades maneuverability for climb rate. Development overview. Fighters were developed in World War I to deny enemy aircraft and dirigibles the ability to gather information by reconnaissance. Early fighters were very small and lightly armed by later standards, and most were biplanes built with a wooden frame, covered with fabric, and limited to about 100 miles per hour. Between the wars, wood was largely replaced by steel tubing, then aluminium tubing, and finally aluminium-stressed skin structures began to predominate. By World War II, most fighters were all-metal monoplanes armed with batteries of machine guns or cannons, and some were capable of speeds approaching 400 miles per hour. Most fighters up to this point had one engine, but a number of twin-engine fighters were built. However, they were found to be outmatched against single-engine fighters and were relegated to other tasks, such as night fighters equipped with primitive radar sets. By the end of the war, turbojet engines were replacing piston engines as the means of propulsion, further increasing aircraft speed, since the weight of the engine was so much less than on piston engine fighters. Having two engines was no longer a handicap, and one or two were used, depending on requirements. This in turn required the development of ejection seats so the pilot could escape, and G-suits to counter the much greater forces being applied to the pilot during maneuvers. In the 1950s, radar was fitted to D fighters, since pilots could no longer see far enough ahead to prepare for any opposition. Since then, radar capabilities have grown enormously and are now the primary method of target acquisition. Wings were made thinner and swept back to reduce transonic drag, which required new manufacturing methods to obtain sufficient strength. Skins were no longer sheet metal riveted to a structure, but milled from large slabs of alloy. The sound barrier was broken, and after a few false starts due to required changes in controls, speeds quickly reached Mach 2, past which aircraft can't maneuver to avoid attack. Air-to-air missiles largely replaced guns and rockets in the early 1960s, since both were believed unusable at the speeds being attained. Most modern combat aircraft can carry at least a pair of air-to-air missiles. In the 1970s, turbofans replaced turbojets, improving fuel economy enough that the last piston engine support aircraft could be replaced with jets, making multi-role combat aircraft possible. With the steady improvements in computers, defensive systems have become increasingly efficient. To counter this, stealth technologies have been pursued by the United States, Russia, India and China. The first step was to find ways to reduce the aircraft's reflectivity to radar waves by burying the engines, eliminating sharp corners and diverting any reflections away from the radar sets of opposing forces. Various materials were found to absorb the energy from radar waves, and were incorporated into special finishes that have since found widespread application. Composite structures have become widespread, including major structural components, and have helped to counterbalance the steady increases in aircraft weight. Most modern fighters are larger and heavier than World War II medium bombers.